Hi, this is the second part of the integration by parts video that I did. In this video I'll just do one more example. Before I start the example, let me just jot down the formula for the integration by parts. The integral of u dv equals uv minus the integral of v du. We're going to use this formula in the process. So my example is the integral of, let's say, x squared plus 1 times e to the power of x dx. In here I'm going to let u be the polynomial, because when I differentiate u, the polynomial reduces to a smaller polynomial. So I'm going to let u be x squared plus 1. Then I'll be forced to have dv be e to the power of x dx, so that u times dv is this expression. And I'll be forced to have du equal to x dx. I just differentiated that. And v is the antiderivative of e to the x, and antiderivative of e to the x, which equals e to the x. So then the integral of x squared plus 1 times e to the power of x dx becomes, let me see, make it smaller a little bit so I can save some room. Okay, so the integral of x squared plus 1 times e to the x dx now is the integral of u dv, which equals uv minus integral of v du. Well, what was u? U was x squared plus 1, and v is e to the x. I'm just putting the stuff those in from that, minus the integral of v du. That's e to the x times 2x dx. I'll simplify this as x squared plus 1 e to the x minus, well, 2 is a constant. I'll take that out and I will rearrange it as x times e to the power of x dx. And this one I'm going to have to use substitution one more time to break this down. Okay, let me change the color. So let's let u be x and dv be e to the x dx. I'm trying to integrate this guy. This will be, this says, well, this implies that du equals, fix that, sorry, du equals dx and v equals e to the x. So then the integral of x e to the x dx is the integral of u dv, which equals uv minus integral of v du. This is equal to uv, x is u, v is e to the x, minus the integral of v du. v du, integral of e to the x dx. This is x e to the x minus e to the x, the plus c. I'm going to put the plus c at the end. So now back to my problem, the integral of x squared plus 1 times e to the power of x dx, which is equal to x squared plus 1 e to the x minus 2 times the integral of x e to the x. Oh, that's crowded, so crowded. I'll put it in the next page. I'll put all of this in the next page. Yeah, remove this guy. Okay. So what I had was the integral of x squared plus 1 e to the x dx equals x squared plus 1 e to the x minus 2 times x e to the x dx was what I had, and the integral of x e to the x dx using u substitution was x e to the x minus the integral of e to the x dx, which was x e to the x minus e to the x plus c. I'm going to ignore this plus c. It's not going to help. So I'll put that at the end. So this is this one here is the integral of x e to the x, which is this guy. So the integral of x squared plus 1 e to the x dx equals x squared plus 1 e to the x minus 2 times x e to the x minus e to the x plus c, or that's equal to x squared plus 1 times e to the x minus 2x e to the x plus 2 e to the x plus c, and that's the final answer, the integral of x squared plus 1 e to the x dx. So sometimes we may have to do multiple layers of integration by parts to get the final answer to our integral. Also, you may have noticed that I let u be the polynomial and dv be e to the power of x dx, and the advantage I get is when you differentiate a polynomial, the power reduces, but e to the x, whether you differentiate it or integrate it, it won't reduce. So to get the advantage of reducing the whole expression to a little simpler expression, I let u be the polynomial, and that's what I got. Thank you. Goodbye.